don't do this. Okay. Okay, so limit x approaches a of the first function, f of x, plus limit as x approaches a of the second function, g of x. Same thing happens with the difference. You can distribute that limit across the differences. So you're going to do limit as x approaches a of f of x minus limit as x approaches a of g of x. If we use these values that they give us here up here, limit as x approaches a of f of x is L, and limit as x approaches a of g of x is M, then this first one I could write as L plus M. The second one I would write as L minus M. Okay, this one says that this term in the front, this C, is just a constant, like 5 times f of x, or -8 times f of x. And what I do for that one is I just bring that C into the front. C limit x approaches a f of x. So this is going to be C times L. If I zoom in, I'll be a little better. Okay, product, same way, distribute it. We don't really distribute across the product, but imagine you could. Limit as x approaches a f of x times limit as x approaches a g of x. So in terms of our two letters, this first one was L, the second one was M. Okay, a quotient is the only time something might go wrong. And when do you think something might go wrong in a quotient? 0 where? In the denominator. If there was a 0 in the denominator, you should think like bad news. So you can distribute it to the quotient as long as oops. So these two things are equal when the limit as x approaches a of g of x is not 0. So if this guy down here was 0, then you can't use that quotient rule. You'd have to say the limit does not exist. Okay, so if that guy there in the denominator is 0, you'd have to say bad doesn't exist. Okay, the last one is power, and you can just put the limit inside the power. Limit as x approaches a f of x to the n. I'm going to need to space that out better next time. The last one, you just put the limit inside the exponent. You see the exponent was just on the function, and then we just now put it on the limit. Okay, so here's a practice problem that tells me that the limit as x approaches 2 of f of x is 4. The limit as x approaches 2 of g of x is 5. And the limit as x approaches 2 of h of x is 8. And it says, can you compute the limit as x approaches 2 of these 3 different functions, which are combinations of those f's, g's, and h's, right? So can you compute the limit of those 3 different functions, which are combinations of the f, g's, and h's?
Can you show me that top part?
Sure. So basically, I'm going to use these rules. I'm going to use the quotient rules. I'm going to use the difference rules. I'm going to use the power rules. And I'm going to rewrite each of these limits into these 3 pieces that I know, into what happens with f, what happens with g, what happens with h. Okay. So I'm going to do the first one, like kind of detailed. And then the rest you'll be like, I don't need to write all that down. I can just do it without that. So the first one says that I can take this limit and break it into 2 pieces, the limit of the numerator and the limit of the denominator, using the quotient rule, right? So I'm going to start by writing this guy as limit as x approaches 2, f of x minus g of x over limit as x approaches 2, h of x. And I can do that as long as the denominator is not 0. Is this limit in the denominator, this h of x limit 0? No, it's 8, right? So I can do that, and that's the quotient rule. So let me write over here, quotient. Okay, now I'm going to break the numerator apart into two different limits. I'm going to say limit as x approaches 2 of f of x minus limit as x approaches 2 of g of x. And that was the difference rule or the subtraction. And once I'm there, I'm going to use these three pieces. They told me that this limit is 4. They told me that this limit is 5. And that this limit is 8. So I'm going to say 4 minus 5 divided by 8, or -1 over 8. And that's my answer. No, you don't have to show the detailed steps. I'm okay if you don't do that. Yeah. So we could keep doing it detailed, right? We could keep using it, writing down which rule we're using. It's not necessary. In this case, if we think about what rules we're going to use the addition rule to separate this, right? We're going to use the product rule because we have the f times the g. And then we're going to use that constant multiple rule to pull that 6 into the front, right? But in reality, what I'm really doing is saying this guy right here is going to be 8. This guy right here is going to be 4. This guy right here is going to be 5, and that 6 is still going to stay there. So I'm going to say 6 times 4 times 5 plus 8. And then you do it in your head or in your calculator. 128. So this limit here would be 128. Okay, this third guy, I'm going to be careful with this third guy again. The power rule tells me that I can move that limit inside the exponent. So then this guy inside here is 5. So this is going to turn into 5 cubed, 125. Yeah. Okay, I want to do one more. What's different about this one than the other 3 that I did? It's got that x all by itself, right? This one has that x all by itself. So I can use the addition rule to separate this into 2 pieces. I can separate it into the limit as x approaches 2 of this function x plus the limit as x approaches 2 of that function g of x. Now this guy I know is going to be 5 because that's what this formula up here told me, right? How am I going to evaluate this guy? Turns out that's our next step, right? Do you know what the graph of this function here looks like? X. What does the graph of x look like? It's a line, goes through the origin. What is the value of the graph? What is the y value or the output of the graph near x equals 2? 2, right? So like by the end of the day, you're going to realize that when you're trying to evaluate a limit, the first thing you should try is to just plug your number in for x. You plug 2 in here for x, you get 2 out. So we're going to say 2 plus this green guy up there, 5. So 2 plus 5 makes 7 today. 2 plus 5 or 7. Okay, let's call that letter D. So this thing here, this limit as x approaches 2 of x, sort of leads us to the question of how do I evaluate a limit when I have an equation? One way is to try to look at the graph, right? Sometimes it's really hard to estimate what your y value is from a graph though, right? Like if they want 1/3 or 1/4, it's really hard to know what that y value is when you look at a graph. And so another way is to try to do it algebraically. And we're going to talk about doing it algebraically. The first step is to plug in your x value. That's the first step. Plug in your x value. If everything turns out nice, meaning you get an answer, there's no zeros in the denominators, there's nothing that's undefined, you're not getting any errors, then you're done and that's your limit. Plug it in, see how it goes, okay? The problem comes in step 2. If you get something that we call indeterminate form. Indeterminate form, which is usually found as 0/0. So let's say you had some sort of function, you plugged in your value. When you tried that, you got 0 in the numerator or 0 in the denominator. We don't know what that is, right? Sometimes that does not exist. Sometimes it could be 1. Sometimes it could be 1/3, right? We don't know what happens. That's why we call it indeterminate form. It can have lots of different answers depending on what happens after that. So if you in step 1 plug in your value and you get this indeterminate form of 0/0, you got to think about do some more work. The kind of work we're going to do is factoring and rationalizing. Those are the 2 main things we're going to do. I'm going to add a third one. Combine fractions, factor and cancel, and rationalize. So these are the 3 steps you can try when you get something that's of indeterminate form. Factor and cancel, rationalize. You know what rationalize means? Yeah, getting rid of a square root, right? When you have a square root, you think like, I don't like square roots in the denominator. It turns out when I get 0/0, I don't like them in the numerator or the denominator. That's rationalizing, is getting rid of a square root. And then combining fractions. Sometimes you'll have 2 fractions divided by a fraction. You'll have to combine them and do some simplifying like that, okay? So these are our methods. These are the only methods we know for finding limits algebraically. Plug in your number. Always try that first. Don't assume because it's a yucky fraction that you're going to have to do some of this stuff. Plug it in and make sure you get 0/0. If you get a number over 0, you don't have to do any more work, right? Like if you get 5/0, you're done. That limit doesn't exist. The only time you have to try to do some more work is when you get 0/0. Okay, here we go. I can tell right away that I will need more space in here. Yep. Let's see how I can do that. That's it. Okay, my first question says, how do I find the limit as x approaches -1 of this function, x squared plus 2x minus 4? So if you're trying to find a limit analytically or algebraically, what should be your first step? Plug it in. What's my x value here? -1. Plug -1 in what? For all the x's. So in here, I'm going to substitute. Yep, I can do it now. I'm going to substitute -1 for all of my x's. Notice my parentheses, because I want to make sure that the -1 gets squared, not that the 1 gets squared and then make negative. So put some parentheses in there. Either do it in your head or do it in your calculator, and you get -5. we could have also seen this graphically, right? I could have graphed this function in Desmos or my calculator, x squared plus 2x minus 1. I could have gone to x equals -1, looked for the y value, and it would have spit out to me -5. But this is a lot easier, yeah? Okay, let's try again. This one has a square root in it. Maybe we're going to have to rationalize. What should we try first? Plug in your number. What's my x value in this case? 2, because it says limit as x approaches 2. So my x value is 2. I'm going to try to plug it in. Square root 3 times 2 minus 2. 6 minus 2 makes 4. Square root of 4 makes 2. Done. Remember, those bottom 3 choices are only useful if you get 0 over 0. Otherwise, proceed as normal. Is it +2? No, if the square root's already there, then they have to tell you whether it's positive or negative. If you take the square root yourself, then you have to put in the positive and negative. Okay, here's one. Oh man, that one looks hard. Limit as x approaches 1 of this fraction 1 over x plus 1. This might not be on your papers. Sometimes I make like last minute decisions. If I get a lot of homework questions, I'm like, shoot, I should do this. Limit as x approaches 1, 1 over x plus 1 minus 1/2 divided by x minus 1. So 1 over x plus 1 minus 1/2 divided by x minus 1. What should I try first? Plug it in. Okay, so I'm going to try to plug it in. I'm going to do it over here in blue. 1 over 1 plus 1 minus 1/2 over 1 minus 1. Okay, 1 over 1 plus 1 is 1/2. So this is 1/2. 1/2 minus 1/2 makes 0. Shoot. 1 minus 1 makes 0. Darn, right? This guy is indeterminate form. It should trigger in your head. Try to do more work, right? Just because you get 0 over 0, do not say does not exist. That's not the case. If I graph this function in Desmos, I'm going to see that near 1, he has a limit. Let's do that. I'm going to pull up my graph in Desmos, and I'm going to see that near 1, this guy has a limit. F of x is fraction 1 over x plus 1 minus 1/2 over x minus 1. Is that what it was? Okay. All right, near 1. Here's x equals 1. Look, at 1, he's undefined. That we knew, right? But do you see his y value is kind of close to, look, if I go a little bit that way, or I go a little bit this way, what would you say his y value is close to? -0.25, right? You'd say to estimate that this y value, this limit, is close to -0.25. So we suspect that in the end, we're going to get out -0.25. Okay, let's try it. Okay, so this guy has a bunch of fractions. So which of those 3 techniques do you think we should use if this guy has a bunch of fractions? Combine the fractions together, right? How do you combine fractions together? You find a common denominator. Absolutely. We're going to find a common denominator. I'm going to make my common denominator 2 times x plus 1. Everybody agree? I'm going to make my common denominator 2 times x plus 1. I took the x plus 1 from this first fraction. I took the 2 from that second fraction, multiplied them together. That's what I'm going to make my common denominator. This might be a trick that you've never seen or that you don't think about to use that often, but when you have a fraction with fractions in the top and then just a plain thing in the bottom, you can multiply every term, 1 over x plus 1, 1/2, and x minus 1 by this common denominator, and it doesn't change your fraction, right? Because you're multiplying by 1, because you're multiplying the numerator and denominator by the same thing. So what I'm going to do is multiply every term of that limit by that common denominator. Notice I wrote limit down again. How come I wrote limit down again? In the end, I want to take the limit, right? In the end, I'm going to want to try to plug in 1 for x. So I'm going to keep writing limit until I actually get to do the plugging in 1 so that I don't forget that I have to do it. Okay, what happens in this first term in the numerator? 1 over x plus 1 times 2 times x plus 1. What happens in this first term? Those x plus 1s cancel out. Perfect. What happens in this second term? Those 2's cancel out. Great. So I get limit as x approaches 1. When I cancel out here, I have a 2. Minus, don't forget this minus, because this minus goes with both of these pieces in here. So minus x minus 1 over, nothing happens in the denominator. I'm just going to keep it all. Okay. It's looking like it's getting better, but it's not quite awesome yet. So let's keep going. Can I simplify the numerator at all? Can you simplify the numerator? Sure. Combine like terms, right? I have 2 minus x minus 1 is going to give me negative x plus 1. Yeah. I would like to be able to cancel this with something in the denominator. Right now, it kind of looks like these two terms are the same, right? It almost looks like those two terms are the same. What's wrong with them? They have negatives, right? If I take this numerator and I rewrite him as -1, take out, factor out a -1, then I'm left with x minus 1. And then I have x minus 1 times 2 times x plus 1. Now they can cancel this x minus 1 and this x minus 1. I'm getting close. I'm almost at the end. It's good because my paper's almost up too. Limit as x goes to 1. I have -1 left in the numerator. I have 2 times x plus 1 left in the denominator. This looks a lot different and a lot simpler than the guy we started with, right? And what you might notice is that in the initial one that we started with, we had an x minus 1 in the denominator, meaning when I plugged 1 in, it gave me a 0 in the denominator. And zeros in the denominators are things that like signal bad things in your head, right? So when I plugged in 1, initially it gave me that 0 in the denominator. Now that term that was giving me a 0, that x minus 1, is gone. So now when I plug 1 in, we suspect and we hope that we're not going to get 0 in the denominator anymore. So now I'm going to plug 1 into this guy for x. We know what the answer should be, right? Remember what the answer should be? -1/4, yep. So -1 over 2 times 2, -1/4. All right, let's go back to this guy. He looks yucky again. Hopefully he's not though, right? Okay, limit as x goes to -7 of 2x squared plus 13x minus 7 divided by x plus 7. What's your first step when you're trying to find a limit? Plug in the number. My number is -7. I'm going to plug -7 into this guy. Okay, I'm going to try to plug in -7. 2 times -7 squared. 13 times -7 minus 7 over -7 plus 7. Okay, I can do the denominator. I get 0. Somebody else will have to do the numerator. Let's see. -7 squared is 49. 2 times 49 is 98. -7 times 13 is -91. 98 minus 91 is 7. Minus 7, 0. I did it. I got 0. Oh, man. I didn't want to get 0. I wanted to get something else. Okay, well, bad news. I got 0. Now what? Use Desmos. Yeah, use Desmos, make some sort of estimate, right? See if we can get it to give us a nice number that we can see. That's an excellent plan. What else? What are those three things?
Rationalize factor.
Yeah, rationalized factor or combined fractions, right? Which one do you think is going to work for this one? Factoring. This is when you're like, I hate factoring when the number in the front is not a 1. Yeah, everyone does. Okay, so we're going to try to factor. I don't know how much factoring practice you need, but in D2L, there's a file under section 1.1. Let me show you. If you go to D2L, you go to our class. I'm gonna drag it over here. If you go to D2L, you go to our class, you go here to section 1, module 1, and you go down, there's this file called Bootcamp Simplifying Expressions. And in this boot camp, it talks to you about factoring and simplifying, and it talks about factoring and rationalizing. So if you find yourself struggling with the factoring and the simplifying and stuff, it talks about it in there. This one's actually pretty easy to factor because 2 only has 2 factors, 2 and 1. So that has to be 2x and x. And 7 only has 2 factors, 1 and 7, right? So I can either put a 1 here and a 7 here, or a 7 here and a 1 there. Yeah, if I put a 7 here and a 1 here, then I'm going to get 2 and 7. And 2 and 7 never come together to make 13, right? But if I put a 1 here and a 7 here, then I'm going to get 14. 2 times 7 makes 14, and 1. And I can combine 14 and 1 together to get 13, right? So I'm going to make this guy 7 and this guy 1. This guy needs to be positive because the 13 in the end is positive, and this guy needs to be negative. That's not the only way to factor. That's sort of the guess and check method. If you remember the, what's it called? One where you do A times C, then you find the pairs, the factor by grouping method. It's been a long week. The factor by grouping method, you can also use the factor by grouping method. If you're like struggling with factoring, like shoot me an email or something and I'll give you some resources. Yeah.
Did you write next to the +7?
This says 2x minus 1, parentheses. Those are 2 parentheses that like merged together. Let me do them better. Like that. All right, now what? Cancel. Yeah, that was lucky. Probably not lucky. We chose it that way on purpose. Equals limit x goes to -7, 2x minus 1. Now the last piece is I got rid of that 7x plus 7 in the denominator, which was causing me problems. Plug in -7 and see what happens. 2 times -7 minus 1, -15. Probably if we have graphed this function, like, tell me your name again. What? Miguel had suggested, we would have found that in Desmos pretty quickly, right? Just wait till we do derivatives. It's gonna be great. Okay, I got 2 more, and then I'm gonna take your homework questions. Which one do you want to do first, do you think? The one with the square root or the one with the cosine? Square root? Look at you guys. All right, fine. I see what you think of pre-calculus. Okay, this guy says limit as x goes to 5 of this thing. Square root of x plus 4 minus 3 over x minus 5. What am I going to try first? Plug it in. Okay, square root of 5 plus 4 minus 3 over 5 minus 5. Well, that 0 in the denominator often says to me, darn, 5 plus 4 makes 9. Square root of 9 is 3. 3 minus 3 makes 0. Dang. Okay, I'm going to try to do something. And in this case, I'm going to do the rationalize. Okay, when I rationalize, I multiply the numerator and denominator by the same thing. In this case, the thing that I'm going to pick is this numerator with the opposite sign in between it. Okay, so this is the thing I changed. I turned that minus into a plus. And that's how I rationalize. It's how you rationalize complex numbers. It's how you rationalize, anytime you're rationalizing square roots, you turn that minus into a plus or the plus into a minus. Now I have to be super duper duper careful because I have this guy, which is a binomial, times this guy, which is a binomial. And when I multiply two binomials together, I need to distribute or FOIL, right? I need to do first, outside, inside, last. In the denominator, I'm not going to multiply those together. I'm just going to leave them like they are. Because remember, my goal when I do this rationalizing or simplifying is to try to make this x minus 5 go away. That x minus 5 was the thing that was causing that 0 in the denominator. If I can make that x minus 5 go away, then all my problems are going to be solved. So I'm just going to leave that x minus 5 there and hope that the numerator will make him go away somehow. So I'm going to write this guy as x minus 5. I know it's a lot of writing, but I'm just going to do it. Plus 3. Okay, now I'm going to do this numerator. To do the numerator, I need to do first these two. So square root of x plus 4 times square root of x plus 4. What do you get when you do square root of x plus 4 times square root of x plus 4? X plus 4. Yeah, that's awesome. Okay, first outside. When I do the outside, I'm doing this square root of x plus 4 times 3. What do you get when you do square root of x plus 4 times 3? 3 square roots of x plus 4. Yeah. Okay, inside, I'm doing this one, this guy, and that guy. So negative 3 square root of x plus 4. And then last, I got one more guy to do. Negative 3 times 3 makes negative 9. Yeah, awesome. Okay. Can you simplify the numerator at all? Yeah, look at this. I have positive 3 square root of x plus 4s and negative 3 square root of x plus 4s. So they go away. And then I have x plus 4 minus 9. What do you get when you do x plus 4 minus 9? X minus 5. Yes, that's what I was hoping for, remember? Okay, and now I say, see you later, alligator. There go those x minus 5s. What's left in the numerator when I do that? 1. Yeah, a 1. Okay, 1 over square root of x plus 4 plus 3. Okay, remember that I carried this word limit through this whole problem because in the end, I want to remember that I have to do what? Plug in 5 for x. Yeah, great. In the end, I want to remember that I have to plug in 5 for x. Okay, 5 plus 4 is 9. Square root of 9 is 3. Plus 3 is 6. So 1/6. Exhausting. Okay, I got one more left. He was way back up here. Hope he's a lot easier because I don't have that much energy left. Okay, limit as x goes to -1, cosine of pi times x. What should you try? Plug in -1 for x. All right, let's try it. Cosine pi times -1. Pi times -1 is negative pi. Cosine of negative pi, let's see, negative pi is over here at the point -1, 0. Cosine is the first one, the x value, -1. Done. Ta-ta. Yes. I just used the unit circle in my head. You can put it in your calculator. Make sure your calculator is in radians if you're putting in the pi. You can put it in your calculator, you can put it in Desmos, so you can use the unit circle in your head or in your paper wherever you keep your unit circle. My kid just learned his unit circle. It's like the funnest thing ever when your kid gets to learn. I know. He's a little bit smart. It is what it is. He's 14 though, so it's time you learn the unit circle, I think. He's in pre-calculus now. Okay, I am ready for Adfinity homework questions. In 2 seconds, I gotta put in more spaces. Did someone raise their hand? Yes, ma'am, I'm ready. $21. Okay, I'm going to show you my 21 and you're going to tell me whether that's the one you want. Yeah, okay. Now I'm gonna get my little clipper out and try to snip it. Snip. New. Copy. Oh, God. Paste. Okay, this is 21. 21. Okay, these guys down here look like all those limit laws we practiced at the beginning of class, right? These guys down here look like the limit laws that we practiced at the beginning of class. The only difference is instead of just giving you all the values at the top of the problem, they gave you a graph and they're going to make you find the values from the graph. So if I'm going to do this first problem, the limit as x goes to 2 of f of x plus g of x, I'm going to say that's the limit as x goes to 2 of f of x plus the limit as x goes to 2 of g of x. So then what I'm going to do is I'm going to go to my graph. And for this one, I'm going to go to x equals 2 on the f of x. This is the f of x graph. Here's x equals 2. What would you say the limit of this function is? At 2. Yeah, 2. It's going to be that guy up there, right? Remember, the limit doesn't care where the filled in dot. It cares that the two sides are meeting. Okay, so this guy's going to be a 2. Plus. I'm listening. No, it's only D&E if it's broken like this one is. You see how those two are broken at 1? Yeah, then it'll be D&E. Okay, so this one I'm going to go to the G graph. The G graph is this second one. I'm going to go near x equals 2. Here's x equals 2. What are you going to say the limit is? 0. 2 plus 0, 2. Great. Okay, next one. I'm going to do the same thing, except in this one I'm going towards 1. You see that? Okay, so for this one, let's use orange. I'm going to do limit as x. I'm using orange. Nope, here's 1. So this guy is 1 right there. See it? So 1 plus, and now I'm going to do the same thing, but on the G graph. So here's 1. What's the limit as x goes to 1 on the G graph? Does not exist. Done. Does not exist. Yeah. Okay, next one. The next one I'm going to do at 0. So this guy's going to be limit as x approaches 0, f of x. Limit as x approaches 0, g of x. This is hard because I have to have the graph and the paper on the same screen. New color. How about pink? Rose, it says. Okay, so this guy is 0 f of x. Here's 0 on f of x. What do you get? 0. Okay, and now I'm going to do 0 on g of x. Here's 0 on g of x. It's like 1.5 almost, yeah? 1 point something. Okay, 0 times 1.5 makes 0. Okay, I'm going to skip to letter E. Okay, I believe that you can do this one. Just do the same thing. I'm going to skip to letter E. What's different about letter E than the other ones? It has that x cubed, right? So for this piece right here, I'm going to use my graph, right? But how am I going to find that piece right there? Plug in 2 for x. Excellent plan. Yeah. So I'm going to say 2 cubed times this guy. I'm going to go to the graph. So I'm going to go to the f graph and look near x equals 2. So for this guy, because he has that f of x in there, I'm going to go to the f graph and look what happens at 2. So here was 2. The limit at 2 was 2. So that was 2 cubed 2 makes 16. Yes, ma'am. Because this guy didn't have any f's or g's in him, so I just plugged 2 in for the x. Yeah. Same thing with this guy. This 3 doesn't have any f's or g's in it, so I'm just going to use the 3, right? This guy's going to be square root 3 plus limit as x goes to 1 f of x. So I'm going to go to my graph for this guy. I'm going to go to my f graph and look near x equals 1. But everybody else I'm just going to get because he was there already, right? So I'm going to go to my f graph and look what happens near 1. So this was my F graph. Near 1, the limit is 1. So that guy's going to be a 1, but nobody else changes. Two. Other questions from your affinity homework?
Really quick about factoring.
Absolutely.
Trinomial.
Yes.
What two numbers do you multiply together?
Yeah. So they need to multiply to make C and add to make B. It's a little bit trickier when that's not a 1 in the front. Then you got to do a little bit more work, but they need to multiply. They multiply to make this number, the C at the end, and they add to make that number, the B in the middle.
Can you do on the
Yeah.
like the other way?
Yeah. Okay, so the factor by grouping method, which is the one I usually use when the coefficient of the A is not a 1. So if the number in the very beginning in front of the x squared is not a 1, I use the factor by grouping method. So it says take A times C and then try to find pairs of numbers that multiply to A times C and add to B. So A times C is 2 times -7, which is -14. So I'm looking for two numbers that multiply to make -14 and add to make 13. So two numbers that multiply to make -14 and add to make 13. 14 and -1. When I do 14 plus -1, I get 13. So what I do is I break this middle term up into 14x minus 1x. So I have 2x squared plus 14x minus 1x minus 7. You can make this table part systematically, right? You could just start with 1 and 14, 2 and 7, right? Just list all the factors. Does 1 go in? Does 2 go in? Does 3 go in? Does 4 go in? List all the factors, see what they add to. If you can find them right away, great. Okay, then what I do is I call it factor by grouping because I'm going to make two groups. I'm going to group these two terms together and I'm going to group these two terms together. If I look at the first two terms, what's their greatest common factor? 2x. If I look at the second two terms, what's their greatest common factor? -1. Good. So I'm going to write this guy as 2x. I'm going to write this guy as -1. In the first one, I'm going to do 2x squared divided by 2x. It leaves me with x. And then I'm going to do 14x divided by 2x. And I'm left with +7. Yeah. Now I'm going to do this one. I have -1x divided by -1 leaves me with x. And -7 divided by -1 leaves me with +7. What has to happen after you do factor by grouping is that these two pieces that are remaining, the leftover stuff, has to be the same. If these two pieces were not both x plus 7, then either it can't be factored or you made an error, right? So if these two leftover pieces are not the same, did you make an error? If not, then say, I can't factor that. They got rid of our phones, and so now all the phone calls we get come to our computer, which is really crappy when I'm trying to teach and there's like phone calls coming. Campus of tomorrow. Okay, so I'm going to pull that x plus 7 into the front. When I take this x plus 7 away right here, I'm left with 2x. When I take this x plus 7 away here, I'm left with -1. So there is my factored form of that piece up there. It's a really good method if this first term and last term have lots of things. Like if this was a 6 and this was a 24, then guess and check would take you a really long time, right? And so this method is really good if those first and last terms have lots of vectors. But if the first and last terms are like prime numbers, then probably guessing and checking is pretty easy. Anything else? Let me stop this.